Hello folks, welcome to this lecture. This is the first lecture of our course Augmented Reality for Everyone. In this course, we are going to get an idea of what exactly is extended reality, what comes under the hood of extended reality. That is, we are going to learn about augmented reality, virtual reality, mixed reality. We are going to learn about the mixed reality continuum. All right. Then we will end this part of the lecture by understanding the growth of the growth of extended reality over the years and what we are projecting by the year 2025. All right. So without any further ado, let's understand. All right. See, extended reality now. Try to understand extended reality in this way. It is the extension, all right, it is the extension of our current reality. All right, you can say that it is the a virtual, all right, it is a virtual extension of our current reality. All right, you can understand extended reality like this. All right, there isn't any specific, all right, there isn't any specific definition that would uh, do justice to this whole domain. All right, but how I like to explain extended reality is it is the extension of our current reality, all right, that and it is the virtual extension, all right, it is the virtual extension of our current reality. You can say extended reality is the hood, all right, means it is the roof, and that roof has three children, all right. Those three children are named as augmented reality, virtual reality, and mixed reality. All right. So, extended reality is the main hood, and it contains three other domains: augmented reality, virtual reality, and mixed reality. All right. Extended reality is the parent domain. All right. Now, as we have understood what exactly is extended reality, right? What are the subdomains of extended reality? Let's understand what is augmented reality. All right. You see, you might have, all right, you might have experienced augmented reality in your life, but you it might happen that you didn't knew that it was augmented reality. Like when you used to play Pokemon Go, when I guess it released in 2016. At that point of time, I was very excited to play that game. All right, just because I could, the spawn the Pokemon. All right, I could bring the Pokemon into the real world. All right, it had a AR feature that could, by pressing the AR camera, we could bring the Pokemon into our real world. All right, I was very excited about that feature. All the reason why I didn't I wasn't able to play the game because I wasn't able to roam around for free. Like it had GPS enabled, right? So the only reason why I played the game was because of its AR feature, and at that point of time, I didn't knew what exactly augmented reality was. I didn't even knew how this thing works. All right, at that point of time, I just started with programming. All right, so we all have used augmented reality at some point in our life and didn't knew exactly what it was, right? So one example you already got, all right, the one with Pokemon Go. Now people used to think that Pokemon Go is one of the biggest breakthrough in augmented reality, but it is not. The truth is this, because see, if you look in after this course, all right, after this course, if you look into that now, creating the mechanism, all right, that is the Pokeball throwing mechanism to the Pokemon, that mechanism is very simple to make. All right, that mechanism is very simple to develop. It's just we are throwing it through a projectile. So understand it like this. All right, basically augmented reality is nothing. Augmented reality is nothing but bringing, all right, that is augmenting, or putting the digital objects, all right, in our case the digital objects, like in Pokemon Go, Pikachu is a digital object, right? So we are taking the digital object, all right, and placing it into our real world. That is what augmented reality is. How we are placing it? We are placing it through our device. All right, and uh, don't worry, we are going to understand, all right, how all these thing works. All right, how augmented reality actually works, right? How, what is the architecture in our future videos. But for now, understand it like this way, that we augmented reality is basically the augmentation, or you can say the placement of digital object in real world. Like for example, take your favorite cartoon. All right, for a long time back, my favorite cartoon was Doraemon. All right, I used to watch it like all day. I love that cartoon when I was like in class third or fourth. So at that time, if I knew about augmented reality, I would have surely tried that. I would have tried augmenting Doraemon into my room. All right, I would have tried that. So just think of it this way: you are actually bringing your favorite digital character. All right, into your real world. So that is what augmented reality is. That is basically what augmented reality is. Alright, it is basically the placement of digital object into the real world. Like, alright, now as I have told you, now you might know, alright, you right now you are aware of what exact how Pokemon Go uses augmented reality, right? Now, what I want you to do is, after finishing this lecture, install that game and try it out. Try it out by yourself. See how exactly the AR feature is working. Alright, it would be really fun, believe me. Now, there are majorly two types of augmented reality: marker-based augmented reality and marker-less augmented reality. Alright, in marker-less, there are four other types of augmented reality. That is superimposition, location-based, projection, and outlining. Alright, don't worry, I'm going to make you understand what exactly are these. Alright, so let's start with marker-based. See, the meaning of this, alright, the meaning of marker based is in its name only. Marker based AR means the augmented reality feature works only if there is a marker, alright. Only if there is a marker to help augment the object, alright. That is what marker based augmented reality is. Basically, now this type of AR basically works on the concept of tracking and recognition, alright. It first tracks the marker, means it first recognizes the marker and then tracks it all the way long. All right, so that is how this marker based AR work. All right, basically in this type of AR, now you will be needing, all right, you will be needing a marker to augment. All right, you will be needing a marker to help augment uh, the digital object into the world. All right, like in here. All right, like in this, you can see that this Lego Batman, all right, or you can say this Minecraft blocked Batman, all right, is being augmented. This particular Minecraft shaped Batman is being what can I say, is being augmented on top of a marker. All right, here you can see it is being augmented on top of a marker. So this is what marker based augmented reality is. To augment this kind of to augment digital object, we would be needing a marker. All right, so that is what marker based augmented reality is. All right, and in this course we will be developing marker based AR. All right, so if you are not clear with the concept right now, that's totally fine. All right, you would be when you will be developing the marker based AR app by yourself, you'll be very clear that how exactly those things work. All right, but for now, in simple words, uh, marker based AR is something, all right, that would be needing, all right, in which we'll be needing, it is mandatory to have a marker. All right, it is mandatory to have a marker to augment the digital object on top of it, or else you won't be able to, you know, or else you won't be able to augment it. All right, so that is what marker based augmented reality is. All right, now Pokemon Go is not an example of marker based augmented reality. All right, I would tell you what example is it for. All right, now let's understand what is markerless AR. All right, now as we have understood about marker based AR, markerless AR is the total opposite. All right, the difference between them is, all right, the difference between them is marker based AR needs marker. All right, that is, it needs some, point, or you can say something to, all right, it needs something to augment. All right, it needs, and that thing is a marker. So marker based augmented reality needs a marker to augment, but markerless AR doesn't. Now, there are some algorithms, all right, like simultaneous localization and mapping is an algorithm that is used, all right, that is used to map the whole, the whole environment around us and then place the objects in there, all right. So markerless AR doesn't need, all right, markerless AR doesn't need any sort of marker. What it does, it will scan the, let's say if I am trying to augment some object in my room, what will it do? It will scan the surface, it will scan the walls, all right. It would create, you can say, it creates a virtual, visualization of itself, and then, it will place, all right. It will place the object right in there, all right. So it would first scan the room, all right. It will first scan the room. After scanning, it will place the object. All right. Now, how it will scan? There is an algorithm. It's a very widely used algorithm. It is also used in robotics, but it is also used in virtual reality, augmented reality, and mixed reality. It is known as SLAM, that is simultaneous localization and mapping. All right, so that's how we build markerless AR features. All right, so markerless AR is very simple. It will, this AR will simply detect your room, or means the plane, the vertical and horizontal surfaces of your room. All right, that is the planes, and perform the augmentation on those particular planes of those objects. All right, means it will augment the digital objects on top of those planes that your AR app has detected. Right, now, for example, in this you can see this IKEA Place app. All right, this is the demo of IKEA Place. Basically, this is a very famous furniture app that makes use of markerless augmented reality to help you decorate your room. All right, like if I, let's say if I want to buy a sofa. All right, like you can see it in here. What I'm doing is I'm installing the IKEA Place app. I'm searching for some sofa in there. I like that sofa very much, but I don't know will that sofa will fit my home or not. Fit my, in the sense, it will look good in my room or not, something like that. All right. Now what I can do is I can make use of markerless augmented reality, scan my room, and then place the object in there. All right, and then through my mobile I can see that if the sofa is adjusting at my place or not. All right, and based on that I can buy the sofa. So that is how that is what markerless AR. All right, now there are multiple use cases of markerless AR. All right, and decoration. All right, means this putting furnitures and all this is one. All right, is one industry focused. All right, it is in interior design is another industry. All right, in where mixed reality. All right, in where mixed reality and augmented reality are widely used. All right, like for decorating the homes and all those things. All right, so I hope marker based and markerless AR is clear. So basically, marker based AR is nothing. Marker based AR needs a marker to perform the augmentation of digital objects into on top of the marker, whereas markerless AR doesn't need any marker. All right, what it will do, it will scan the surface and then augment the digital objects on top of the surface. All right, so that is the basic difference, and that is what they do. All right, now let's get into the concept of superimposition based AR. All right, see, superimposition based augmented reality, all right, is basically a technique that uses object recognition. Now in this diagram, all right, in this diagram you can see there is a person's hand. All right, there is a person's hand, and on top of that hand, what this app is doing is displaying a skeleton of the hand on top of the person's hand. All right, so that is what superimposition based AR is. It superimposes. All right, it superimposes. That means it puts an digital object on top of a real object. All right, and that works with the help of object recognition. All right, so that is what superimposition based AR is. It's very simple. All right, it's very simple. Now, all right, see what is happening in here. Basically, with this photo, all right, you can say that we are able to augment a skeleton of hand on top of another person's hand. All right, so what is happening, the algorithm, all right, that is the AR app, is recognizing the hand, then putting, all right, or you can say then superimposing, all right, superimposing the skeleton on top of that hand. All right, that is what it is doing. That is what superimposition based AR is. All right, very simple. All right, now these type of AR is very helpful. All right, in medical industry. All right, like you can say you can superimpose an X-ray, all right, on a patient's body and look into it real time in 3D. So how cool that would be and how efficient that would be, right? That would make the doctor's job more easier, right? So that is how we use superimposition based AR. All right, and superimposition based AR are used in in many different ways. So you can do your research on that. All right, and even if you like, you can try developing something with superimposition AR also. All right, so you can totally do that. That would be real fun. All right, so that is what superimposition based AR is. So I hope you are clear with the very fundamental concepts right now. After this, we are going to get into this location based AR. All right, see, location based AR now, let me tell you, I'm sure you know about GPS, right? You know about what can I say? Google Maps, right? So you can say this is Google Maps in augmented reality. All right, like in Google Maps, when you search for a place, what it does, it gives you the address of that place. All right, means it marks the road. It will highlight the road through which you can go. How much time will it take? All right, it will label the places that will come while you are going in there. Right, it will label those places. But what you are doing in there, you are seeing all those in a 2D screen. All right, what location based AR does is it's also does the things almost same, but in augmented reality it would give you the live feed, all right, in 3D. It will give you the live feed in 3D, like you will be, if you are going somewhere, you if you turn around, you would be seeing a nameplate, all right, hovering over a building. All right, that would give you an idea, yeah, this is the building what I'm looking for. All right, then you can go in there. So this type of AR experience makes it more easier, all right, to use like locate places. All right, so that is what location based AR is. Location based AR basically ties digital content and the experience it creates to a specific place. All right, the objects are mapped out so that when a user's location matches the predetermined spot, it is displayed on the screen. All right, so that's what I told you just now. All right, this is the definition. This is, I gave you the very simple explanation of the same definition written in here. All right, so location based AR is just like Google Maps but in AR. All right, and more efficient, more better. All right, in a more better way. Of course, now you guys might be thinking why we are going to held our phone in hand and start looking for places. All right, it's going to be very hectic. I totally understand that. All right, and that's not how we are going to use location based AR. Currently, there are multiple AR glasses that are being released. All right, like GeoGlass is releasing their own AR headset. Then Qualcomm, all right, Qualcomm is releasing their own AR headset. All right, so many people, many industries, all right, are working on their own AR and MR headset. Then Magic Leap is there. So when those glasses will release now, after a few years, all right, or maybe in this year only, you will be seeing location based AR. All right, it would be GPS but in AR. So how cool that experience would be, right? So that is how these things will work. So I hope this the concept of location based AR is clear. All right, now here comes projection based AR. Now let me make it simpler for you. All right, projection based AR is another name of holograms. All right, I know you guys might have an idea about what exactly a hologram is, right? It basically projects. All right, it is projecting with a a projector role into means into the means what let me explain it in a simple way. What it is doing, it is like with a normal augmented reality, all right, that is being used by a phone. The difference between projection based AR and normal AR is, we are in normal AR we are using our phone to augment. All right, we are using our phone to augment, but in projection based AR we are using some other device to project. All right, to project the digital object into the real world. All right, that gives a more immersive experience. In that case, you are not going to need an phone. All right, you are just having some projector and it is projecting. All right, it is projecting the 3D objects in the real world. People are working on this kind of technology. All right, although right now it hasn't been that successful. All right, but people are working on that, and I'm sure this is something that we are going to get in future. All right, and people are really working hard on this kind of AR. All right, it would be like really cool, like you would be the Tony Stark, all right, of real world. So yeah, augmented reality, virtual reality, and mixed reality has the potential to bring all the things that you see in the Iron Man movie. Of course, not the arc reactor, but all the digital things like the Jarvis. All right, artificial intelligence is also having those potential. So if we combine these technologies, now we can have something like Jarvis. So understand it this way. All right, augmented reality, virtual reality, and mixed reality is the future of our world. All right, maybe within 5 to 10 years you won't be even using your phone. You will be having slim glasses. All right, you will be having slim glasses through which you will be able to augment the digital objects, all right. And that is going to be true because we have those glasses now, all right. Yes, they are bulky. Like if I take an example, there's Microsoft HoloLens, all right. If you have used that before, you would get the same experience like Tony Stark, right? Similarly, then other AR glasses is being released, like Geo Glass is releasing their own, then Qualcomm is releasing their own. So within 5 to 10 years, all right, you won't be using your phone to communicate or do things. You'll be using your AR glasses to do all the things. All right, there's Snapchat's lens. All right, so a lot of things are there that you can do. All right. So now, as we have understood the very basic concepts, the concept of extended reality, or we have understood the basics of augmented reality. We have understood marker-based AR, markerless AR, superimposition, location-based, and projection-based. And the last one we have in the topic of augmented reality is outlining AR. All right. Now, what exactly is it? All right. Outlining AR is are mostly used in cars. All right. You might not be seeing them more often. All right. Although I guess even Tesla is working on implementing AR in their cars. All right. So basically, outlining AR, it will outline the direction. All right. It will map the world and then outline the direction. All right. With these trails. Here you can see. Right. Here you can see. So they will outline those trails and help you, you know, go through all the paths. All right. It would recognize the boundaries. All right. It would recognize the lines. It would help in many situations. All right. When where human eye can't. All right. So augmented reality is the future. All right. Augmented reality, mixed reality, and virtual reality is the future. So this is how outlining AR is used. All right. Even if Tesla is working on implementing augmented reality, all right, then why can't we? Right. We are developers. We can do that. Of course, we can do that. So you can see people are working on implementing AR in their cars. Right. How cool is that? Right. So that is what outlining AR is. All right. Now, as we have understood the fundamental concepts of augmented reality, let's get into the virtual reality. All right. Virtual reality is the total opposite of augmented reality. In augmented reality, what did we do? In augmented reality, we were augmenting, all right, or you can say putting the digital objects in the real world. But in virtual reality, we are taking, all right, we are taking the person itself to the virtual world, all right, or you can say we are teleporting the person to the virtual world, right? So that is what virtual reality is, and it gives a very good sense of immersiveness, all right. For example, all right, see, even I don't have a VR headset, all right. Uh, let the truth be told, all right. I don't have a VR headset. I don't, but I do have the understanding how it feels, all right. Because at somewhere, all right, at somewhere I have used, at some part of my life, I have used virtual reality headset. Yeah, of course, not at my home, but when I used to go to some game parlor, all right, they had a virtual reality experience, all right. I am, I have used, I know how that feels, all right, and I'm glad that I can explain it to you that try to understand it like this. All right, let's say you are playing a game. All right, take any of your favorite game. All right, one of my favorite game is GTA 5. All right, although I don't play games much nowadays, but if I had to say, one of my favorite games is GTA 5 and GTA San Andreas. All right, so what I'm going to do is I'm going to close my eyes and think of a character in there. All right, think of a character in there and try to close my eyes and try to experience, all right, all that thing by myself. All right, and the level of immersiveness you will get there now, like while thinking or while imagining you are in there in real time in the game and playing all the things, doing all the things that the game's character can do, will give you a sense of immersiveness. And using virtual reality, that sense of immersiveness increases by 100%. All right, because at that point of time you are actually in there, you are actually controlling the person available inside the game, right? You are actually able to control the you know you are actually able to control the character available inside the game. So virtual reality is nothing but it is a technology that teleports you to a virtual world. All right. So that is what exactly it is. Now there are multiple games and educational applications available, right? For example, uh, anatomy U, all right, it teaches you about the human anatomy, all right. So that is an educational app, all right. Then there is Beat Saber, one of the very famous game, like in the first image you can see this is the gameplay of a Beat Saber, all right. In the second image this is a gameplay of Half-Life Alyx, all right. In the third image this is the battle royale game. Yeah, there is also a battle royale game in virtual reality, so you can see the level of immersiveness, the level of realism you will be getting. This is called what can I say, standout VR battle royale. All right, so the VR can be used in multiple sectors. It can be used in healthcare, it can be used in military training, all right, it can be used in flight training, it can be used in manufacturing, all right. It can be used in education, it can be used in gaming. So the what can I say, the level, all right, or you can say the limitation of VR is unreachable. All right, yeah, there is some limitation, all right, like the cost is there, all right, but cost, cost is decreasing. Like previously in India, all right, I'm talking about in India. In India, previously, Oculus Quest, all right, it's a VR headset. It used to cost around 80 to 90,000, I guess, all right, and now Oculus Quest 2 costs you around 30 to 40,000, all right. So you can see how drastically has the price has the price has decreased by half, all right. So the price of VR headsets are decreasing, all right, and also the quality and the technology is improving and increasing, all right. So just a few more years and you'll be getting VR headsets maybe in 10,000 or 20,000. So things are things are happening real quick, and mixed reality mixed reality is going to help us a lot. If I talk about in the manufacturing industry, all right, if I talk about the military training industry, all right, and as we have understood about the virtual reality, augmented reality, it's our high time to go to mixed reality, all right. Now let me tell you. All right. Also, one thing I forgot to tell you, that if you are using virtual VR now, you'd be needing an headset. That headset is called head-mounted display. All right. So you make sure you know that this term. All right. Or you can say in abbreviated form, it is also called HMD. All right, or head-mounted display. Now, see, mixed reality. All right. Mixed reality now is the, you can say, it is the brother. All right, this is the brother, or the twin brother, you can say, or you can say just the brother of augmented reality. All right. Why? Because see, it is, let me simplify this term to you. Mixed reality is just like augmented reality, but yeah, there's a but it is more advanced, all right. It has more capabilities than normal augmented reality. Why? All right, see, there's something called, all right, mixed reality continuum, or you can say mixed reality spectrum. What does that mean? It means that the merge, all right, the merge of augmented reality and virtual reality, or you can say the real world and virtual world or digital world, all right, we combine them. You can you know go virtual and real at the same time, all right, with mixed reality. So mixed reality has a larger potential if we talk about the like training industry, all right, like in manufacturing industry, mixed reality can help you, to recognize those items, all right. It can help you through the manufacturing process. In healthcare, all right, it can help you, operate a patient, all right. It can guide you through all the things. You don't even need to, distract yourself to any other computers or digital objects available in the ICU, all right, you can say, or in the patient's ward, all right, where basically the operation is happening, all right. You don't even have to move from the patient. You can stay in there, monitor all the things, all right, in your MR headset, all right. Monitor all the, let's say heart rate or blood pressure or any data through your MR headset only. All right, so this is how it can help in medical industry. Then military training. Recently, I guess I just read somewhere in 2018, all right, in 2018, military, all right, I guess US military reached Microsoft and offered around 400 to 500 billion dollars to build mixed reality headsets for them, all right, for training military, all right, for training the military. So you can you can you can just think how powerful these headsets are, all right. It can help in training. So mixed reality can help you anywhere, like for example, in India there's a startup called Ajna Lens, all right. What they are doing, they are creating headsets for government which are being used to train military, all right, Indian military. So it is being used to train Navy SEALs. They are it is being used to train numerous people out here in India. So you can see how mixed reality is exactly helping, right? So mixed reality, I would say mixed reality is future, all right. Extended reality is the future of our world, all right. It is the future of our world. So mixed reality is nothing but it is the advanced form of augmented reality. All right, it contains both. It means it can go both virtual and real. All right, so that's what mixed reality is. All right, and you have already understood the mixed about the mixed reality spectrum. That is the combination. All right, that is the combination of physical and digital world. All right, so that is what mixed reality is. All right, and also this image is taken from Microsoft's website. So yeah, now as we have understood all right about all the things all right about mixed reality, augmented reality, virtual reality, let's get our heads into the growth of XR, all right, or you can say the growth of market of extended reality, all right. See, the extended reality market size, all right, is going to reach, all right, around $393 billion by 2025 at a growth rate of 69.4% CAGR. All right, it is a report by Market Research Future. All right, now you can see that in 2017 the growth was so less. All right, means there wasn't any awareness of augmented and virtual reality, but you can see by 2025 what will be the growth, all right. You can read this chart by yourself, all right. So you can see how it is impacting. Now I want to tell you that this chart, all right, this chart is this chart is not stable, all right. Right now in 2022 only, the market has reached more than $200 billion, all right. So you can see how the growth is actually, but it can even happen by 2023, all right. By 2023 it can even reach $393 billion, that is estimated by 2025. So all right, so make sure you go through all these notes, all right. All the notes will be available in the website, so make sure you go through that. So yeah, that's it for this lecture. Thank you.